All right, there's one thing I wanted to go into before we do more advanced examples of graphing cubics, and that's if we've got a minus out the front. So if we have y equals minus, minus 3 outside of x take 2, x plus 1, x plus 7 or something, then we still know that it's going to go through the x-axis this one's going to go through at positive 2 because I did everything the wrong way around. And that means I'm going to have to kind of move this one a lot over this way. And just ignore that. Positive 2, negative 1, and negative 1, 2, 3, 4, 5, 6, 7. So we do know it's going to go this way. But because this one has a minus out the front, we're no longer going to start down here and then do that thing. Now we're going to start up here and do that. And we honestly don't know what kind of a shape it's going to take. We don't know how high it's going to go in between each of these. They don't turn around halfway between each of the x-intercepts. It's all a bit random. I wish I'd drawn that better. Let me have another go. Oh gosh, okay, I can't draw today. Sometimes though, you'll get something where it only goes through one root, like here, and it kind of bounces back at this root. So this one, we're going down here, we're bouncing back up, and we're going all the way down. And let's say we wanted to find an equation for this. Well, the fact that this one's bouncing up means that this is actually two roots. At x equals 1. Which means when we come to write our equation, I don't know what the number out the front is going to be, but I dare say it's negative because it's kind of starting in the top left, not the bottom left. I know that it's going to turn around at x minus 1, but it's going to do that twice because it hits it and then turns back around. And then it's going to go through x equals positive 4, so x take 4. Which means we've got a outside of x take 1 squared, x take 4. So whenever you have something bouncing back around like this, it means that it's squared. That's all. And now if we actually wanted to find the equation of this, well, the only unknown I have is a. This is the point 0, 4. So I'm going to do this like we did with the quadratics. 4 equals a times 0 take 1 squared, 0 take 4. 4 equals a. 0 take 1 squared is 1. 0 take 4 is negative 4. So 4 equals a times negative 4. So a is negative 1, so y equals negative x take 1 squared, x take 4. And that's kind of them. I'm going to record the question, like me answering some of the questions in the textbook in different videos. So let's go on to different harder questions. For example, if I had this example, this is way harder. Whoa, what's going on here? I'm going to do something else first. If we have generic polynomials, like x to the 7, take 3x to the 6, plus 2x to the 5, take 4x to the 4, etc., etc., you won't ever be asked to graph one of those, but you might be asked to graph one that's already been factorized. So for example, if I had y equals x take x plus 5, x plus 1 squared, x take 3, then that's actually a quartic, because we've got like 4 factors with x. That x plus 1 squared counts as 2. So I know it's going to go through x equals minus 5, x equals minus 1, and I know it's going to hit right there and bounce back off, and x equals positive 3. The only thing I don't know is if I'm going to go... Oh, sorry, I missed that completely. So it'll hit off here and then go back up, or if it'll go up like this and back down there. So what I've really got to do is test like a point, oh sorry, I meant to do that with a highlighter, a point down here to see if it's negative or positive. That's kind of, or even a point up here to see if it's negative or positive. So what's something, this is x equals 3, this is x equals -1, and this is x equals -5. So let's test, what's more than x equals 3? X equals 5. Actually, no, I'm going to do x equals 4. Why make it complicated? Y equals 4 plus 5, 4 plus 1 squared, 4 take 3. And I already know that each of those is positive, so it's going to come out as some big positive number. Which means when x is 4, we must actually be up here instead of down below. Because y is positive, so we must be above. Which means for this one to be positive here, we must have to bounce off here and then back up. And that's it's kind of as hard as it gets. Actually, I say that, but I lie. Let's have a look at one more example in the book. I'm going to have a look at this example, but I'm going to cover out the solution. Okay, so here we've got a squared, so it's going to either bounce off it like that or bounce off it like that. And here we have another one. So let's draw our axes. Y. Yeah, you're even less precise with these than we were with quadratics, and we weren't that great with quadratics. X, we've got, let's get rid of this. We've got x plus 1 squared, so it's going to be at -1. And it's going to bounce off twice there, x minus 1, so +1, and x minus 3 squared, so plus, and it's going to bounce off there. My only problem is, I don't know if it's going to go bounce, down, bounce, or if it's going to go bounce, up, bounce. So we need to test one of the values in this region, or we could do one of the values down here, see whether it comes out positive or negative. I always like substituting in positive numbers, so this is 3, so why don't we do 4 again? So x equals 4, y equals negative. Why did I do 4x when I know that it's going to be 4? Well, because that's what I've chosen. Plus 1 squared, 4 take 1, 4 take 3 squared. So I've got a negative outside of, well, this is a positive, this is a positive, and this is a positive. So a negative times a positive squared times a positive times, it's going to come out negative. So it's not going to be like this at all. It's going to be going downwards here. So it bounces off here because that's a squared. We go through here. We don't know whereabouts it's going to turn around. And it bounces off there because that's another squared. So what is happening at x equals -1 and x equals +3? It turns around completely at those points. Those points. Later on, you're going to learn that the proper terminology for that is a stationary point, but you don't know that, so shh. Sorry, soup. Must be gross listening to my soup noises. Alright, I'm going to leave this here and I'll work through some questions as well.